Hi, I'm teacher Minerva. Today we will be talking about the different types of nuclear reaction that leads to the formation of new elements. Before we go to details on element formation, let us familiarize ourselves first with the symbols of different particles in the nuclear reaction. Notice that each element or particle has a superscript and a subscript. The superscript is the atomic mass, and the subscript is the number of protons or the atomic number. The X could be the element symbol or the particle. So what is nuclear reaction? A nuclear reaction is a process wherein the nucleophile element will go through fusion or fission to form a different particle or a new atom. The interaction involves the emission of radioactive particles such as protons, neutrons, and electrons called radioactivity. There are five most common types of nuclear reaction. First, alpha particle. Alpha particle is a radioactive process in which an alpha particle is emitted from the nucleus of an atom, decreasing the atomic number by 2. This is the symbol. The alpha particles have a mass of 4 and a charge of 2. It has the same nuclei as a helium atom. That is a mass of 4 and a charge of 2. Therefore, we can also write it either way. Another radioactive process is beta decay. Beta decay occurs when one of the protons or neutrons is transformed into the other. This is the symbol beta. Beta particles have a mass of 0 and a charge of -1. Another radioactive process is positron emission. Positron emission is a subtype of radioactive decay called beta decay, in which a proton inside the radionuclide nucleus is converted into a neutron while releasing a positron and an electron neutrino. This is the symbol. Positron emission is a mass of 0 and a charge of +1. Next we have electron capture. Electron capture is analogous to positron decay, except an atomic electron is captured by a proton within a nucleus, resulting in the emission of a neutrino. The symbol of electron is E, and it has a 0 mass and a charge of -1. Another radioactive process is gamma radiation. Gamma radiation are waveless packets of energy called photons. Unlike alpha and beta particles, which have both energy and mass, gamma rays are pure energy. Gamma rays are similar to visible light but have much higher energy. This is the symbol, and it has a 0 mass and a 0 charge. Let's do some examples in nuclear reaction. Let's start with alpha decay. We have magnesium as an example. Magnesium has a mass of 24 and 12 as charge. What if this element will undergo alpha radiation? What happens during the process? Alpha radiation is a mass of 4 and a charge of 2. Now both sides of the equation must be balanced. Magnesium has 24 less the charge of alpha particle, that is 4, equals to 20. And for the charge, it is 10. 12 minus 2 is 10. Now if we're going to look at the periodic table of elements, the element that has an atomic number of 10 is neon. Therefore, the new element that was formed during alpha decay is neon. Next we have beta particle or beta decay. Let us have magnesium again as our example. How about this element will undergo beta decay? Again, magnesium has a mass of 24 and a charge of 12. Beta decay has 0 mass and a charge of -1. Again, let us balance the mass and the charge to know what is the new element that is formed. Since beta decay has a mass of 0, therefore the mass of the new element is 24. For the charge, since the beta particles is -1, we will add it to the charge of magnesium, that is 12. So the new element is 13 as atomic number. If we look at the periodic table of the element that has 13 as an atomic number is aluminum. What is the effect of beta decay? Notice that in the beta decay, the atomic mass did not change. However, the atomic number increases from 12 to 13. The atomic number is the proton of the element. So what happens to the neutron? Neutron is the difference between atomic mass and proton. So 24 minus 12 equals 12. The neutron of magnesium is 12. For the aluminum, 24 minus 13 is equals to 11. So the neutron of aluminum is 11. During beta decay, the proton of an element increases by 1 but loses 1 neutron and an electron escapes. Next, positron emission. We take oxygen as an example. Oxygen has an atomic mass of 16 and 8 is charged. We are going to produce a positron in the reaction. An oxygen with a mass of 16 minus 0 from the positron or electron, it remains the same, that is 16. The atomic charge of oxygen is 8, less 1 charge from the electron, so the answer is 7. Again, in the periodic table, the element that has an atomic number of 7 is nitrogen. So the new element that was formed during the positron emission is nitrogen. What is the effect of positron production? The atomic number, which is also the proton of an element, decreases by 1. What happens to the neutron? Again, the neutron is the difference between atomic mass and atomic number. For the example, oxygen has an atomic mass of 16 minus 8 protons, so we have 8 neutrons. For the new element, that is nitrogen, the mass is 16 minus 7 is equals to 9. With this, the neutron during positron emission increases by 1. The proton is converted into neutron. So during the positron effect, the proton decreases and converted into a neutron and a positron releases. A positron is an antiparticle of an electron. Gamma radiation. What happens when beta particles and a positron get together? They will cancel out and releases gamma radiation. They will annihilate each other. Last, we have electron capture. Sometimes the nucleus of an atom can capture one of its inner core electrons. We have calcium as our example. Calcium has a mass of 40 and a charge of 20. If it captures one of its inner core electron, what is the resulting element? Since the electron is a mass of 0, the mass of the new element remains the same, that is 40. How about the charge? So 20 minus 1 is equals to 19. So what is the resulting element? Again, in the periodic table, the element that has an atomic number of 19 is potassium. What is the effect of electron capture on the nucleus of an atom? The proton will decrease by 1 and the neutron will increase by 1. These are the most common types of nuclear reaction. Have fun learning!